1.
Hi everyone and welcome to the Festive Tech Calendar 2022. Today's session is about having a festive time with AKS Networking. I'm Philip Welz, working at White Duck, and I'm a senior Kubernetes DevOps engineer focusing on Kubernetes on Azure and automating infrastructure with Terraform, Bicep, and all the tools you can find. With me, I have my colleague.
Nico Meisenzahl. Hi everyone. I'm Cloud Solution Architect at White Duck, and I'm mainly focusing around helping our customers to build and deploy and run cloud native applications on Azure.
Okay, so today, as we mentioned, we talk about AKS Networking. We will do a briefly intro into AKS Networking. We will talk about control plane and networking options you have with the Azure Kubernetes Service. We will introduce the Cilium-powered data plane, which is a new feature. We will cover this later, and we will introduce you to some private AP server options you will get from Azure. And to get started, we will do the intro to AKS Networking. And here we have several layers the AKS Networking stack will provide us. So we have pod-to-pod traffic, we have pod-to-service networking traffic, we have in-cluster DNS, we have ingress and egress, we have traffic between the Kubernetes control plane and the data plane, and we have the API server access. In our session, we will not cover all the topics. We are focusing really on the pod-to-pod traffic, which is the basic layer in the Kubernetes network setup. We will focus on traffic between the Kubernetes control plane and the data plane, and we'll talk about the API server access options you will get.
Okay, so with this, I would like to start talking about the control plane options you will get with AKS. So before I start, the control plane in AKS or Kubernetes, mainly, as Phil already mentioned, is used for the pod-to-pod communication in the cluster. So when one application needs to talk to another application, this is basically done by this control plane. And it's basically a mandatory feature. Without that, there's no network available in the cluster, and no of the applications can talk to each other, even though, for example, ingress controller can reach a pod instance and so on. And yeah, to implement this kind of east-west traffic networking, there are multiple options in AKS, and this is the first part we would like to talk about. So basically, you have the choice. There are many options with different pros and cons. Yeah, starting with the first, or before we start with the first option, briefly talk about the underlying interface Kubernetes uses here, and it's called Container Network Interface, short CNI. And basically, this is an abstraction layer, an API interface which allows to inject any kind of networking solution as so-called plugin into your existing Kubernetes cluster. So basically, it's really an abstraction layer. It's vendor neutral, which means basically you have multiple implementations, open source implementations, third-party applications, and so on, which can then be integrated to help you with networking your Kubernetes cluster. This is also not limited to Kubernetes itself. Also, for example, Mesos or Cloud Foundry also using the container network interface for the networking stack. As I said, the so-called vendor implementations or open source implementations are called plugins, and we also included a short link to get you started on the container network interface topic. So first implementation you can get with AKS is the so-called Kubenet. Kubenet is basically the default implementation by Kubernetes. So it's basically the default thing you will get if you do not configure anything else. It's very basic and very simple implementation, so it really only covers the basic functionality to get a network for pods to communicate with each other. So it's mainly used for single node deployments, or in cloud provider scenarios like with Azure. Basically, it's a combination between Kubenet and the underlying virtual network infrastructure of the cloud provider, because Kubenet itself only covers networking on a single node. So you have no option to talk from one node to another node just with Kubenet. So it's really very basic. but still there are some use cases where you can use it. Also, any kind of advanced features like, as I said, cross-node networking or, for example, network policies are not supported. This is also completely based on Linux technology, so also there's no support for Windows nodes and Windows pods, for example. We are talking about Kubenet and AKS. We have some limitations or some settings which we need to know. Basically, Kubenet requires outgoing internet connectivity, so it's not a really good option if you go with a complete private AKS cluster. You also need one subnet in your virtual network in Azure per cluster, and you also limit of 400 nodes in a Kubernetes cluster. This is mainly due to the limitation of root tables in Azure, which we talk about in just a sec. Also, if you would like to talk from a pod to something outside your Kubernetes cluster, like a managed offering, database, Deutsche account, and so on, and due to the design of Kubenet, it's basically one hop, one additional hop, which then also, is not the best network performance if you have workload which basically talks with something outside the Kubernetes cluster. Also, as I said, network policies are not yet supported, at least the Azure networking policies. If you go with the Calico option in AKS, Calico also supports Kubenet here. And other features like, for example, the virtual node add-on, which integrates Azure container instances, is also not supported with the Kubenet option on AKS. Just a small overview how Kubenet works. As you see, we have two nodes here. On the left side, we have node 1. We have pods here, and the node itself has its own virtual network. So this is basically really a virtual network which gets provided by Kubenet, injected by Kubenet. And then if the pod needs to talk to something outside this node, could be a different node, could be a managed database or any external resource, then basically there's a routing and netting option here, which basically then allows to talk to the Azure Virtual Network, where all of the nodes in the cluster are linked to. And this is basically then the option to communicate from one node to another node. You have one additional hop here, and basically you really need to rely on the routing tables here, which then also introduces the 400 node limit due to the root tables limit in Azure here. Yeah, but still a valid option. Maybe some details when to use Kubenet with AKS. Kubenet supports dual stack, so if you need IPv4 and IPv6 inside your cluster, the really as a dual stack, Kubenet can help you with that one. Once again, due to the additional hop, it's only recommended when most of your communication is within your cluster. So pod communication or not outside to your cluster, and also if you don't need any advanced AKS features like, for example, the virtual node option with ACI. On the other hand, it was more important earlier. Kubenet is a really nice option when you have limited IP address spaces available in your Azure environment. But this is already in brackets because there are some better options coming, which Phil will talk about later. But still, if you have limited IP spaces, Kubenet could be a nice option for you. With this, I would like to hand over to Phil to talk about the next options we have.
Okay, additionally to the Kubenet option, Azure provides us with 3 other options. We have the Azure CNI, which is basically the Azure implementation of the network plugin. We have the Azure CNI Overlay, which is a preview feature at the moment. And we have also a really new is Bring-Your-Own CNI. We will start with the Azure CNI, which has also some additional features like dynamic IP allocation and advanced subnetting. So the Azure CNI is really flexible, so it supports Windows nodes. It has advanced features where you can split your node pools across several subnets. So every node pool gets an own subnet. You can use nodes in one subnet. You can really configure the Azure CNI in the way you want your cluster, and also it's really flexible in extending this. It's get even more flexible, as I mentioned already, with the dynamic allocation and the advanced subnet support. What the Azure CNI will do when you don't use the dynamic allocation is that you have your subnet and your nodes, and when Kubernetes by default configures the max pod limit of 110, the Azure CNI will pre-allocate this 110 IPs in your subnet. So these IPs are blocked and cannot use anymore. I think the default for Azure CNI is at the moment 30. When you create it with the Azure CLI, when you create it with the portal, the max pod limit is 110. So think about configuring your max pod limits will pre-allocate the IPs in your subnet. And if your subnet is too small, you will have this IP address planning issues, which we also going to cover later. With the dynamic allocation as a new feature, you create your own pod subnet just for the pods. So the nodes are in one subnet, the pods are in one subnet, and the IPs are dynamically allocated and not pre-allocated. This is a real new feature and can help you with the IP address planning, which sometimes occur if networks are too small. And here we have a brief overview. The Azure CNI, as you can see, the pods are directly in the subnet of the host. So there's a direct communication. It's a layer 3 routing. Microsoft or the Azure CNI, I think in 1.2.0 switched to the transparency mode. So now we have really layer 3 routing. Before it was layer 2 or MAC based. This has several downsides like DNS flooding issues, MAC issues. So that's why we're now using the transparency mode with layer 3 IP. And what you can still see is that all outgoing traffic will flow through the host's IP. So in the cluster, you can direct route to everything because it's a layer 3 routing, but outside connections are still routed through the IP of the host. So every application outside will see the host IP of the cluster. And then when you should use CNI, so from our side, it's most of the time because you get the advanced features like I mentioned, the Windows node pools, the flexible setup with the subnets, and the dynamic IP allocation feature. So, and the advanced features, like I mentioned, is also when you have not enough. So when you have enough space in your subnet. Sorry. So when your virtual network is big enough, use the Azure CNI. If not, check out the other options we will mention now. The new feature is the Azure CNI Overlay. Before on the slides, maybe you saw it, we call it the better Kubenet because it works nearly in the same way as Kubenet work, but it has some options which you will maybe benefit you. So you can add up to 1,000 Kubernetes nodes. You have no performance degrade because of the implementation of the networking layers, a little bit better than the Kubenet. You have full support for network policies. So the Azure network policies, the Calico network policies are implemented. So you're free to go there. You still, it's still only supported for Linux, as is the preview feature. So maybe Windows node support will come. We have to check that. But there's no support for at the moment for virtual nodes, and also the I think the Azure application gateway Ingress controller is not supported with the overlay at the moment. So you have to check the limitations out. And now we have a small overview. Basically, as you can see, every node has its own subnet. There's a pod CIDR defined on every node, and together over this subnets from the pod, there's an overlay network span, which will ensure pod-to-pod communication on Kubernetes level. Still, we have the NUT outside, so it's a little bit performance decrease because you do the nutting always compared to the Azure CNI where you have direct communication. And the last option, sorry, when you use the CNI overlay, when you have want to scale your nodes and pods, but you have limited IP address space due to, I don't know, regular restrictions of your company. And if you're an enterprise and you have just one small net, then you should think about the Azure CNI overlay compared to the Kubenet. You should also use it when most of the communication is within the cluster. Because of the nothing feature, as we discussed about, you will see maybe a slight increase of latency and network performance. If you want Kubernetes, use Kubernetes network policies and don't want to use the Calico plugin, then you should also use the Azure CNI Overlay. And if you don't need this advanced AKS features like splitting node pools in different subnets and so on. So this is where you really want to use the Azure CNI Overlay when it's GA. And the last feature is the Bring-Your-Own CNI. It's also new. Basically, when you spin up your cluster, you will see that the cluster is there, but all the nodes are in status not ready until you bring your own CNI and install a network plugin into Kubernetes. So you can deploy your CNI of choice, for example, Cilium, or I don't know any other, but Cilium. The downside is here, you have no support by Azure if you have networking or CNI issues, and the limitations of the network and how many pods, how many nodes is based on the chosen plugin. You can check out the link, use Bring Your Own CNI, and you will see the what you need to do in order to set it up. Okay.
Okay, so with this, we're coming to the Cilium-powered data plane option, which is pretty new in AKS. So this feature is still in preview, but what you will get is basically a managed Cilium offering powered by the Azure team within your AKS cluster. So Cilium can help you with the pod networking, also with the Kubernetes basic network handling, like I said, the pod-to-pod communication, also network policies, and basically doing that on a really high performance level, because Cilium is based on eBPF. So basically all the things Cilium does for you are pretty fast and really high performance, and this is really one of the big use cases or pros of Cilium. So as I said, all the routing, all the communication is done by eBPF, and also the load balancing internally is done with socket-based connections instead of IP table routing here. Still, the Cilium implementation is then based on the control plane we already talked about. So still we have the Azure IP address management, which is really then connects the Cilium installation with the Azure virtual network world here. And because of that, the Azure CNI powered by Cilium is supported by Azure CNI and also the new Azure CNI overlay option Phil just mentioned. So we're really flexible with both of them, just you're not able to use Kubenet with the Azure CNI powered Cilium here. So maybe short intro what Cilium and Azure CNI doing together. As I said, it works with overlay mode, it works with vNet mode due to the Azure IPAM integration, and then you can use Cilium for your network policies for all of the service and load balancing within your cluster. And the Cilium then uses eBPF within your Linux kernel to really root and inject all the stuff here, and doing this very, very performant. Maybe doing a quick intro to eBPF, really just a quick one. I think eBPF is on topic on its own. So basically, when to use eBPF, or what is it? So basically, you have different use cases. Could be networking related topics, could be security related topics, observability and tracing and so on. And there are already many projects out there, like, for example, Cilium or like Tetragon and Falco doing security observability in your cluster. And yeah, what eBPF does, it's basically a way to run your own code secure and sandboxed within the Linux kernel. So basically, you have an option to extend the Linux kernel with your own code and really run it in the kernel, and this is what it makes it super fast and super high performant. So basically all the things we just talked about, like networking, like security, like observability, are completely integrated into the kernel, but this doing on a secure way, on a sandboxed way. So this is what eBPF allows us to do. And this is basically the baseline for tooling like Cilium or Tetragon or Falco, for example. Of course, you can also build your own. eBPF, yeah, let's call it applications, and run it in a cluster. And therefore, you also have SDKs for Go, for Rust, for C, and so on. Yeah, which help you building your own tooling. So just to give you a brief overview what eBPF is, and this is basically the baseline for the Cilium integration in AKS here. Yeah, some benefits, of course, we have a faster service routing due to the eBPF integration, more efficient network policies, also due to the eBPF integration. We have better observability of the cluster traffic. We have support for larger clusters. So we have higher limits with the Cilium integration. And also we're getting access to the whole Cilium ecosystem. For example, the network policy editor or Harbor, to see in Prosig, or to get an overview observability of your network policies and stuff like this. So basically, this really brings you then into the whole Cilium ecosystem you might already know. We also have some current limitations, mainly because it's really pretty early and preview still. So we have a limitation that is only supported by Linux. Of course, it's eBPF, so yeah. We have a limitation on Linux here. The Cilium network policy custom resource definition is currently not supported. And with this also layer 7 policy enforcement, as we know it from Cilium and Harbor, are not yet available. I hope they're working on that one. I'm not 100% sure, but I would love to also see this one in a later stage in this offering here. If you need any advanced Cilium configurations or would like to start with Harbor directly, you can still go back to the Bring-Your-Own CNI feature and then really deploy and manage Cilium on your own. But then, of course, it's not the managed offering anymore, but you have the full flexibility and can use all of the Cilium features you already know. But this we're going over to the private API server options or all API server options. With this, back to you, Phil.
Yeah, and the first option you have is the API server private endpoint. It's based on private link service or private link endpoints from Azure. The AKS do it a little bit slightly different than the other services. So basically, your API server is as an endpoint supposed in your subnet. But it's just the API endpoint of your Kubernetes, how you manage or talk with the Kubernetes. You can still expose services externally. This is a complete different area. But you have to think about the DNS resolution, DNS resolver, public DNS entries, and also how to deploy to your Kubernetes with a private or self-hosted build agent, or use GitOps in the cluster. And you can also use the AZ AKS command invoke, which basically spins up a pod in the cluster and runs your command, and you will get the result. What you have to do is just to, when you create a cluster, say, hey, it's a private cluster, and provide maybe the DNS, the private DNS zone, and the AKS service or the Azure API will manage all this needed entries for you, so you don't have to manage this the settings. So just specify one flag or specify the flag in Terraform or whatever, and yeah, you're good to go. This is basically the easy option, except the thing how to reach your API server and how to deploy your applications. You have to think a little bit, do a little bit more thinking here. And the last option, or the next option, is with Nico again.
Yeah, so it's the API server vNet integration. This is also still in preview, but a really nice feature, as Phil just said. It's basically the API server, normally just a public endpoint, or with private link, you can inject it into your virtual network. But it's still not part of your virtual network. And with the vNet integration, you can really delegate the API server to expose directly to your subnet. So then this is really a resource living in your subnet. And this really helps with the communication between the API server or the control plane and the data plane, the pods and stuff like this, because without vNet integration, this is done via a private tunnel. There's a project called Connectivity. You might have already seen it in your kube system namespace. So it's basically a pod running in your AKS data plane on your nodes. And this pod then connects to the control plane and really make sure that the data plane can talk to the control plane living somewhere else. And with the vNet integration, you basically can skip the connectivity setup here because the API server is really exposed to your subnet, to your Azure Virtual Network, and then you have a direct connection between the data plane and the control plane and so on. So it's really, I guess, the better option here. And it is also nice, this works for private as well as public clusters or API servers. So you can also then expose your API server with vNet integration still into the public internet. But if you go with a private cluster, you can then completely skip the private link endpoint stuff and just expose it to your virtual network here. So you have your full flexibility and a better integration of the control plane into your into your AKS cluster. We also added here a link for any further details on how to set up the preview. As I said, it's still in preview, so I wouldn't run it in production so far, but it's a really nice feature. Looking forward to get this GA. But this, we are at the end of today's talk. If you have any questions, feel free to ping us on social media. So we can find us on Twitter, on LinkedIn, also via email. And if you would like to get access to the slides, you also find the link here. But this, thanks for joining our talk. Have a great festival season and see you soon. Bye-bye.
Bye.